Yes, sir.
Okay. So think about this scenario. So this again that this also I think it is available if you go to that site. Uh, this is the site name. Anyway, I'll share the document. So conjoint analysis, I think we have discussed this. So this is nothing but a trade-off analysis or considered jointly, right? So that's why it is the name. It's conjoint analysis. This example is limited to responses. So we collect 12 choices from 100 to 2000 respondents. Okay, rather than going through it, let us go through directly through an example. Okay, let's say similar type of question, not exactly the same of what I had given you. There are two so these are the attributes what we have discussed. Brand is one attribute, pack format is one attribute, fat content in that milk is another attribute, price per liter, right? So I have for each of the attributes, I have two labels, not necessarily that need to be same. Like per attribute, it can be 4, 5, another attribute might be 2, right? But ideally, it should be 2 or more. It cannot be that, okay, if one attribute is there, only one label. That should not be there ideally. So I have a brand and I have two different kind of one is supermarket brand, one is a trademark farm grade. Supermarket brand, let's say whatever, let's say Big Bazaar or Reliance Mart, their own branding they're putting and selling it. Farm gate, let's say something similar to let's say Homepage or Amul or let's say your Milky Moo. Okay, pack format, carton or bottle, fat content whether 2% fat or 3% fat. Then price per liter is $2 here and it is a $2.55, right? So the problem, if you remember, we have what we have discussed, right? If I give like and go and ask to a customer, right, which pack format you like, some of them will say carton and some of them will say bottle. If I say what kind of fat content, some of them will say 2%, some of them will say 3%. But when I go to the pricing, right, all of them obviously, if I give them which price point you like, always they'll go for the lower one. But in reality, for a company, those options are not available, might not be available or might not be profitable, right? So what we are trying to do through conjoint analysis, we're creating different product concepts, right? So if I take a supermarket brand with bottle with 2% fat content with price per bottle is $2.05, right? $2.05. That will become a product concept. Like you have done, I had given that for your ITC, right? So how many product concepts can be created? So because I have two attributes in the brand, 2 multiplied by 2 here in pack format, multiplied by 2 again fat content, multiplied by price per liter. Total 16 product concept can be created, right? So, so however, if you see here, it is written that also we have 4 attributes with 2 labels each. However, commonly we do research on more labels and attributes, which is the reality, right? Whenever you are comparing different product, it is not necessary that only two companies, two brands you are looking. There might be 5 or 6 brands are there, 4 or 5 different price point, similarly different packaging also, right? So that's why the number of options, number of product choices will increase in real when you are doing. So what actually we are going to ask in a conjoint? So if you remember the same exercise what I had asked you to complete, right? So it is creating different product sets, right? So in the choice set one, let's say it created a this is a concept. So how it get? So it has taken brand, farm gate, pack format carton, fat content 3% is $2. So this is one product A. This is product C. So now what I'm asking to the customer or to the respondent, choose any product, right? And there are different type of conjoint. This is where your choice based conjoint is happening. There is a rating based, there is a ranking based. Then I will discuss those things in the slide. Here if you see, this is a choice based. I'm giving you certain options, certain choices and asking you to choose one of them, right? So I ask a customer, I give so these three product choices, right? So it is a combination of all these attributes at different levels. So I ask and that customer chooses product A. So this is what is happening in the front end, right? When I'm showing to that option to the customer, that customer is choosing one option. But what is happening in the back end? Obviously in the algorithm automatically happening, but when I say back end, if I'm doing it manually, I'll download the data and carry out that analysis in Excel, what we're going to do now. So what actually is happening here? So I have three products. If I look into product one, for each label, the dummy coding has happened. I think all of you know about dummy coding. So if I go back here again to the inputs, okay, in the top it is not given. Okay, here it is given. A brand, if you see supermarket brand, Farmgate. Supermarket brand is dummy coded as 0, Farmgate is 1. So if I had through 3, let's say, uh, for brand, let's say there are 3 labels, or for any of the attributes there are 3 labels. How many dummy codes I would have created? Because here everything is 2, right? I should have additionally created one more variable. Because then in that case, what would happen? Let's say supermarket brand, Farmgate, let's say another is, let's say Walmart or something else, or a local brand, right? In that case, I would have created one more dummy coding, one more 0 or 1 would have come, right? But in this case, because I have very simple example, I have only 2 choices. One of them I am choosing as 0, right? One of them I am choosing as 1. Why this is important? When we put that into regression, we'll come to know, right? I hope all of you remember how to put a regression, how to create a regression line. Similarly, carton, pack format carton is described as 0, bottle is described as 1, 2% is 0, 1, 3% is 1. So I'm categorizing all those labels, whatever under each attribute, right? I am putting dummy coding to it, right? Uh, because here each one of them have 2 labels. I'm putting one of them as 0, other is them 1. And it is up to you. It is not necessarily the left one you have to put 0, right one is to 1. It is up to you which one you are considering 0. But one of them you are considering as 0, other one as 1, right? Same thing if you see here, what has happened for each label, Farmgate, if I go back and see in my input, Farmgate is 1, right? Farmgate will be coded as 1. If I come back to conjoint question, so this product A is nothing but brand Farmgate, so that's why label is 1. Similarly, product A is carton, pack format is carton, carton is actually, if I go back and see in the input, carton is 0, right? So what is happening? Rather than writing in this textual format, now I can code the product. So if I ask that, okay, product A is nothing but 1010, right? So 1 means brand label 1, pack format label 0, fat content label 1, price per liter label 0, right? So that is the meaning of coding the your answers. Similarly, product 2 also 1100, product 3 is 0011, right? So this is the coding which has happened for the product labels or product, different product options. So when this person is choosing, right? So I am asking that person to choose only one product, right? Let's say he choose product A. So this will be 1. If he chooses some different product, so see the choices, it is becoming 1 here. So this, because out of these 3 products, 1, 2, 3, he chose 1, right? So like that, I can ask, if you see like different customers, different product settings I have given, right? If you see this for the some other person product A, B, C, I'm giving some other set also. It is not necessarily the same product. Here product C was supermarket brand carton 3% is $2.55, but here it is Farmgate bottled products 2% is fat content and $2.05, right? Then that person chose product C as his or her choice, right? Same thing again, coding has happened. Not necessarily every choice you have to code. Once you get the responses, you have to code that, right? How they have responded. Like that, I have created another choice set 3, and I have asked again these 3 different products. What will be the choice of the customer? Product C. So he has chosen product C. Like that, I have given 10 questions, 10 different set of choices, and different customers have chosen different choices, right? Whatever is optimal for them, right? I'm not asking them each attribute what you choose. Overall, these are the 3 products, which will be your choice, which one you are going to purchase, right? Then the next step is to how we are calculating how much for that customer price is important, how much for that customer fat content is important, how much. So when I say per customer, overall whatever answers I've got, right? How much for that customer pack format and brands are important, right? So what it has done here, actually it has directly calculated. I'll show you through regression also. So the same answers what we have received here in the conjoint questions. So they have done what? So they have just put here in this box, right? What are the choice set? Choice set one. What are the answers you got? Choice set one is this product one, this is product two, product three. Out of these three product, right? The choice was for the product A, right? So this is where your choice was put here is one and 0 0 here. Similarly, for the product set choice two, the product C was chosen. So 0 0 in product A and B, 1 is in product C, right? Similarly, all those 10 choices. So in the product choice set, whatever this 10, choice set 10. So out of three products, product C was chosen, right? So because we are always asking the customer to choose only one product, right? So I'll come back to this calculation because here it the like Excel file did not show how to calculate. So what I have done, same like kind of information what I did, I put in a tabular format. So this is your dependent variable, this is your choice, right? And this is the brand, pack format, fat content, and price per liter. So when I'm going to form a regression line, what I'm going to form is how a choice of a person, right, whether that person is selecting the product or not, is dependent on these four attributes: brand, pack format, fat content, and price per liter, right? So these become my dependent variables, and these become my independent variables, and these become my dependent variable. Now I can go ahead and put my this data analysis. I'll go to regression. Input y range is my, so that is my dependent variable. Input x range is, so because I'm selecting the labels, I'll select label. Output range, let it be. Okay. So these regression statistics actually we are not that much interested here because we are only interested in this part of the equation, whether they are significant or not, right? So if you see, we are mostly interested in these coefficients, right? So how much, what is the coefficient of brand, what is the coefficient of pack format, what is the coefficient of fat content, what is the coefficient of price per liter, right? We are much more like kind of interested in these attributes, right? So first part is to understand what each attribute's importance is, right? For a choice of a product selection, right? So that part is easy to do. So if I go back here and I'll show the same calculation, let me just copy it here. So if you see, they have done it nothing but here the same thing. So this we got from our regression, right? So brand, if you see 0.62, here it is written 0.62. So they have also used that Excel file which you downloaded from here. 0.62, we got 0.62, then pack format 0.03, 0.0 minus 0.03, fat content minus 0.12, then price per liter 0.16, right? So they took that absolute value, then sum it up, that is 0.93. If I divide 0.16 by 0.93, that will give me the 17%. So that is a relative importance, right? Because all this, if I add it up, it is not becoming 100, right? So I'm relatively trying to see that if I compare this, obviously I'm not interested in the model intercept. I'm interested in these four attributes only, right? Price per liter, fat content, pack format, and brand, which is the most important attribute, right? Out of this, if you come, brand comes as the most important attribute because that is the most important attribute, which is kind of making that whether that customer will that make a choice or not, choose that product or not, is impacting his or her choice, Brand is the most important factor out of all these factors, followed by obviously price per liter, then fat content, then pack format. So pack format is the least kind of in this comparison, obviously, when it's a least compared to other three factors or other three attributes, right? Is there any question? How did that software got these numbers? Sorry. So now the next step is to find each label, right? Here, because we have only two labels, right? Price per liter, we have two labels of $2 and $2.5. One label we had considered as zero, right? So when I say this price per liter is impacting minus 0.16, what it means in comparison to, because I have created a dummy coding. So this minus 0.16 is for the label which is one, which was one. If I go back and see here one for the price per liter, $2.55 was one, right? So if I compare $2.55 with $2.05, right, the impact of $2.55 is reducing the choice by 0.16, 0.16, right? And that is the reality, right? If I ask a customer to choose one same, all things remaining same, two packets, one is costing $2.05 and other is costing $2.55. Obviously, most of them will go for the least price one. And if you see the results are showing that the minus 0.16, what it shows basically, if the weightage of $2.05 is zero, right? So regression coefficient in a dummy coding, I hope all of you remember, right? The base category level will be taken zero. If the other labels in compared to the base label has a positive impact, the number will be positive. If negative impact, number coefficient will be negative. So here, what does minus 0.16 mean? In comparison to the base level which is zero, that is $2.05. The impact of $2.55 is 16%, 0.16 less than the means that is negatively, that is basically reducing your choice, because what we are trying to predict whether a person will choose a price or not. So in comparison to $2.05 product, $2.55 is 16%, 0.16 less, right? So this is what they've done. They're not either I can keep it like that, I can just keep it this zero and this as minus 16%. But what they've done, they've centered the coefficient. So difference between 0 minus 1.6, right? So rather than doing that, they have taken this one to positive. So added 0.08. So price per liter 0 has a 8% impact positive, and this has minus 8 points impact. So that the difference in impact remains same, right? Visually it becomes little bit easy to show the difference. But this is not required as long as you have this. So you can always say, and I have only two labels, I can say that this is, when I'm comparing two labels, this is zero. And if you see in that graph also, if you have carried out that conjoint analysis, there also you can find out within labels what is the difference between those labels, the impact of the weightage or the importance of each label, right? Similarly, for fat content, I had considered 2% as zero, 3% is minus 0.12. So how do I interpret this? If I'm increasing the fat content, less people will choose my product, right? Because the from 2% to 3% when I'm increasing the fat content, the choice, the probability of choice or the increase in choice is actually reducing. The choice is actually reducing, right? By 0.12% or 12% or 0.12, right? Then again, they have centered it. Then carton bottle. If I consider carton as zero, right, which was done in the dummy coding, choosing a bottle, right? So people are preferring carton better than bottle, right? Maybe they're like whatever environmental conscious and all those things. People will prefer to buy a carton product, a packaging, carton packaging rather than this bottle packaging. Similarly, supermarket, farm gate, if you see the branded product has the very high kind of coefficient score 0.62. That means it has around 62 percentage impact on the choice, right? And that is the most highest kind of attribute level, right? So is this part clear? So if you see in your conjoint analysis, these are the numbers what you will receive, right? And apart from that, there is some McFadden's R square, which is nothing but some customized R square for conjoint analysis, right? So I'll share this. Anyhow, you can download this also. Uh, I'll share this along with this a regression what we have run, so that you know that where the software or where they get these numbers, right? Any questions, any doubt on this? So in case you do not have access to tool or software, we simple obviously a lot of additional analysis cannot be done. If I want to predict market share, that cannot be done through this Excel. For that you will be needing, because they will simulate the results, right? Again, I will not say that it cannot be done. You have to know that how to run a simulation in Excel, so you need certain additional expertise, right? But at least the simplest part, right? If I just want to understand each attribute, what is the weightage, and label wise what is the difference in importance, these two things along with your R square can be carried out in Excel without getting into the high end softwares, right? Carrying out a conjoint analysis. So I have taken this example from the book Marketing Research, which is Das and Malhotra. So they also like similar type of analysis they have done. Let's say I have two people, there is a shoe company like Nike or Adidas. They want to understand which will be the customer preference for certain type of shoes, right? So they have three different, so attribute is whole. So they have three labels: rubber, polyurethane, plastic. Then the upper part of the shoe, it can be leather, canvas, and nylon. Then there are three price points: $30, $60, $90. So if you see how many product choices they have, 3 multiplied by 3 multiplied by 3, 27 product choices, right? So out of those 27 product choices, the software had chosen 9 profiles, right? So in the other case, what we did in that Excel file, if you see, we are showing some choices to customer and asking them to choose a product. So that is choice based conjoint. There is also something called rating based conjoint. So this is it. So if I show you a profile, sole is one means what? This is plastic sole, then upper is one, upper is one means nylon, then price is one. Price is one means $90. If I show you plastic, nylon, and $90 shoe, what was the customer's rating? So this is what customer has given rating 9, 7. So in a scale of 1 to 10, how much the customer is rating that product, right? More the rating means, as you know, that more the rating, better, right? So customer is preferring that product much better. So if you see, that's why I repeated some, let's say product number 3 and product number 5, they have both the same rating, and it can happen also, right? I can equally like the product, right? So I have shown that customer. So this is the difference between rating based conjoint and what we just saw, or what the exercise you did. So that is a choice based conjoint. I'm showing certain products to a customer and they're choosing a product. Now what I'm asking the customer, I'll show some product to you and each product you rate in a scale of 0 to 10, right? So 0 means you do not like it, and 10 means it is the most preferred product for you, right? And if you see, the product 1 was rated 9, which was highest. Product 2 and product 8 was rated 7. Then few of the product were rated 6 and few of the product were rated 5. 5 is okay, average, like kind of preference, right? So same thing if I put in a regression line. So these ratings will be my dependent. These ratings, whatever numbers I have got, right? These will be my dependent, and these attribute labels will become my independent scores, independent numbers, right? And if you see what is this, so we are at the end, we are creating a equation. This is the basis of conjoint analysis model. What is our belief is that a UX is nothing but overall utility of a product to the customer is nothing but combination of at label wise weightage the customer gives to each of those attributes, right? Because in the back of our mind, we have some equation or algorithm running on whenever we see a product, whether to buy that product or not. It is not that we are writing that equation, but if you see this sometime, like not necessarily exactly the same, but similar to this, something is going on in the back of our mind. So where we are telling our utility for a product is nothing but a combination of alpha is nothing but the part worth contribution, right? So like we saw, brand of that milk, packaged milk has a 62 percentage weightage, right? Similarly, let's say other watch some 17 percentage, 18 percentage weightage. So that is there in our mind. So if I go and ask to a customer how much weightage you'll give to a brand, he or she might not tell. But when I'm asking them to choose a product, indirectly I'm able to find out what is the weightage they're going to or giving to those kind of products, right? Am I audible? Hello. Am I audible or is there any disruption?
Yes, sir.
Okay. So dummy coding I have shown you, like for each of the labels you show a dummy coding, like you create a dummy coding, like keeping one label as uh, kind of base, right? You code the other two labels, right? One or zero, right? So that you know that, let's say label one, if I want to code, I have three labels, right? I create two dummy variables. So label one means 1 0, label 2 means 0 1, label 3 means this is the base label, nothing is there means label 3, that is 0x1 plus 0x2. So that is how you do a dummy coding, right? Number of variables you have when you create dummy coding, number of variables minus 1. So to dummy code three variables, we are creating basically two dummy codes, right? So same like exactly what we did for our that excel file, right? So 9 preference rating for the product, these are the attributes, these are the under each attribute, different attribute, these are the labels. Soul, we had three labels, but if you see, we are not showing here three labels. That three labels, rather than showing three labels, we are showing two dummy codes, x1 and x2, right? Similarly, upper x3 and x4, price x5 and x6. So these are nothing but, if I run that regression, like I showed you, these are the coefficients which will come from that regression table, right? b1, b2, b3, b4, b5, b6, that coefficient table has come. So this B1 is nothing but the difference, because what is B1 means? The difference between label 1 and label 3 for the product that is sold, for the product attribute that is sold. B1, this coefficient, whatever we are getting, that is nothing but the difference in choice between label of, so what was the label of sold? One, two, just a moment. One was plastic, polyurethane and rubber, right? So the difference of choice between plastic and polyurethane, that is B1. The difference in choice between polyurethane and whatever the rubber, that is B2, right? So and overall, so that is where the centering, like they showed, that was 62, 62 minus 62 and 0. They centered it and put it as 34%, 34%. Same thing they're doing it here. All the coefficient, all the labels together, it is 0, so that they'll center it around. And if they solve this equation, if they solve this equation, the answers what they getting, what we got actually, right? The weight of the, let's say this sheet they are showing for the soul, and there are three labels. Weight of label 1 is 0.778, weight of label 2 is minus 0.556, weight of label 3 is minus 0.222. Plastic, polyurethane and rubber. See the weight of, if you're showing the customer a plastic sole, the customer is much more like there is a good probability or good chance that that customer will choose that product in comparison to, again it is obviously relative, in comparison to polyurethane or rubber. Similarly for the upper also, they have done those calculation and they have got those numbers. Now what happens, what is the relative importance of rubber in relative importance of sole, relative importance of these attributes, right? So overall they will sum it up like we did. So in the excel file, if you remember, total we added up 0.62 minus 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 absolute values, obviously absolute values we added up, it was coming as 0.93, right? So what we did, 0.62 divided by 0.93, it was 68%, right? Same thing here. So total whatever your attribute, for each attribute you get a score, right? Add that up, and try to find out the relative importance of each of those attributes. So if somebody asks me which is out of these three attributes, which is the most important attribute in a choice of a shoe for a customer, price came to be the most important attribute, followed by the bottom part of the shoe, sole, and upper part of the shoe is the least important among three options, right? Three attributes, right? So this is what they have calculated. Same thing we showed in the Excel. This was the importance score. For us, the brand came as 0.62, followed by, let's say, the what was that? I think the pricing 17%, followed by fat content. Least was the packaging format, right? In this case, the bottom part of the shoe 0.286, 28.6 percentage weightage, upper part of the shoe 21.4, and price is 50 percentage, right? Most of the times this happens once you put price as a parameter, right? And if it is a big difference, in our case the difference was only 50 cents, right? Half a dollar. But here if you see there is a $30 difference in each of the choices, right? Then obviously the most weightage will go to the price, because customer is intangible benefits, customer comparing is very difficult, but once you show a price point, automatically in our mind that calculation will happen. So whenever you are carrying out conjoint analysis, remember that whenever you are putting prices, whether how much difference in prices, if you show a product with $10 or 100 rupees and another with 1000 rupees, no matter what is the impact of other attributes, price will become the most important attribute. So in this case, like you saw, $30, $60, $90, because the price difference is $30, around 2000 rupees, then like kind of people will always go for the price as, or the automatic result of price being the most important attribute will come, right? That is where that is something which you have to remember when you are running conjoint analysis. Then goodness of it, basically we did this r square value is a 1, though it is not exactly accurate, but to certain extent we can know that if r square is good means our model is fitting properly, right? Then test retest reliability. If I'm conducting the same conjoint across different cities, different locations, am I getting the similar result? So conjoint analysis should be done repeatedly. With one analysis, I should not say that okay, this is the result I got and I should prove that, because this is different from the hypothesis testing, right? Here we are not starting with a hypothesis. Here it is kind of a mix of a exploratory and experiment design, right? That's why we have to do it repeatedly. The evaluation of the holdout and validation, like in your data analytics, we have a like training data set and testing data set. Same thing you can do it here. Some choice set you do not show to the customer. You, let's say I have created 12 like kind of different products concepts. 9 product concept I go and show to the customers. I get the result. Then I estimate what will happen to those other 3, right? And when I go to the customer and show these other 3, I'll be able to compare whether whatever I predicted is coming correctly or not. Now what happens when I'm showing the choices, I do not have any prediction. So what will happen, I'll create 12 different product choices. Out of that 9, with 9 I'll go and do this conjoint analysis. Whatever results I get, I'll try to say that whether that results are giving me the same answer for my holdout set. Holdout means something think that as your testing data set or validation data set. So like in our case, in the data analytics we have training, validation and testing data set. Here we have the actual data set which will show to the actual product concept which will show to the customers, and holdout or the validation samples, right? If an aggregate level analysis has been conducted, the estimation sample can be split in several ways. Conjoint analysis conducted on each subsample, right? This is where like sample wise or the uh, subsample wise conjoint analysis can be done, because see, let's say I have doing it for 1,000 customers, 500 customers. Now I want to understand whether there is a difference between male and female. So out of 500 customers, if let's say there are 300 male customers, 200 female customers, I'll divide that and try to understand whether there is a difference between these two different subsample of my whatever customers, right? Critical issues obviously is the sample representative. That is anyhow, anytime you carry out a research, any kind of study, that is the most important question you have to ask, whether the customers or the respondents who are taking that study of conjoint or any kind of study, right, is the representative of the overall sample, overall population, right? Then the next interesting question is, should each person have one vote or should the respondent be weighted in some fashion? Because see, those people who are responding, some people might not have used my product because I've asked them to fill the conjoint analysis, they're just putting that. So how much weightage I'll give to their answers vis-a-vis somebody who is a regular user? He has a better idea about my product, about my brand, right? Second part, obviously, in the amount of money they spend on my brand. If a person regular consumer or somebody who is like occasionally buys my product, right? So somebody who is, let's say, think about this for a Netflix or like OTT platform. Somebody who is a premium customer who is spending a lot of money, who is using different aspects of that OTT platforms, right, through different devices. And another somebody, sometimes he takes a license for 1 or 2 months, then gives a gap. Another sometimes they use it again, right? So shall I make both the customer equal and shall I consider their choices as equal, right? Or shall I give the more weightage when I'm making this calculation for the person who is a regular customer to me? Does the utility of one attribute depend on the level of another? This is the most kind of critical aspect, because what happens if both are related? Let's say the package size is related to your price, because packaging is one attribute. Package size is 200, 300, 250 ml. Price 20 rupees, 25 rupees, 30 rupees. Obviously, there will be relation, right? That is somewhere you have to understand that it is not there will be there will be chances this will happen, but you have to make choice sure that whenever you are making showing to that customer, uh, kind of reliable or real choices are being shown. It should not be such that you are showing a 200 like kind of 200 ml bottle with 10 rupee price and 500 sorry 200 ml bottle with 50 rupee price and 500 ml bottle with 10 rupee price, because that combination might also come. So that combination you should not show to the customer, because that combination is not real. If you're asking a software will just multiply and create different product concepts. But when you're going and showing to the customer, this option won't happen in reality, right? A package, let's say packaged milk or packaged soft drinks, 500 ml costing 20 rupees and 200 ml costing 50 rupees for the same product, same brand, won't happen. So that is something you have to, before launching your conjoint experiment, you have to be aware of, right? Will people do what they say? Obviously, that is true for any kind of research, whether it is a survey research or conjoint analysis or any kind of research. The customer is choosing that, okay, I'll give a rating of 9, but when he is going to the store to buy a shoe, whether he is buying the product which he has checked as 9, or is just going buying a product of 5 because it is in heavy discount, right? So that is always, and it is not along only with conjoint, any kind of survey. The problem is if I'm going and asking customers, respondent, and they're giving some answers, what is the guarantee that they will continue doing that in the future, right? So any questions, any doubt on this? So different type of conjoint, rating based, I just showed you. So rather than providing that which product or which shoe will select, we are asking that customer to rate each of the product concept of different shoes, right? In a rating scale of 1 to 10. It can be of 0 to 100 also. Best worst conjoint, right? So there what we saw, out of these 9 products or 8 product or 6 product concept, you choose the best one and the worst one, right? So how it helps, rather than customer going through all the product rating each of them, what they're doing, the task becomes little bit simpler for them. I show you 5 products or 10 products, I just ask them, choose the best one, which you will select, choose the worst one, right? Ranking based content, which is basically kind of a similar to rating but little bit different. In ranking, I'm asking because ranking cannot repeat. So that is the difference between rating and ranking. Rating, same product, same like different products. Out of 9 products, I can rate all 6 products, same rating of 5 or 6. Other 3 products, same rating of 7 or 8, right? That is possible in a rating. But when I'm ranking has to be relative. Once I rank a product one, there is no other product which will come become rank one, right? So there I am forcing forcing the customer to like make the choices. Okay, out of 9 products, which one you are going to choose, right? So this will be little bit robust than the rating, right? Now I'm like asking the customer to make a choice out of 9 products, right? And then the choice based conjoint, right? So this is what actually in the software what you did. You created different choice set, different products. Now you are asking the customer to choose one product out of them. Most of the times 99, or if you see that statistic, 90% of the times most of the softwares has been developed in this kind of creating choice based conjoint. So choice-based conjoint is much more preferable whenever you have less than 5 attributes. Otherwise, what will happen? Many more choices, many more product options will happen. Customers will get bored. Customer is not going to answer all of those choices, right? Advantages: less abstract, more like real life decision, and that is what happens, right? You do not, the customers do not go to a store and rank product or rate product. They go and make a choice out of 10 products they see, and they choose a pant or a shirt or a whatever they want to buy, or they want to buy some daily usage product out of different milk option, different soft drinks option. They choose one, right? So they are not going to rate or rank anything. So this actually reflects the actual scenario in life. What happens can be conducted via computer phone. That is anyhow like we are using a software allows for more factors labeled the traditional conjoint, right? Disadvantages: static doesn't add up to respondents choices. So because I am showing a set of choices, you choose one of them which you are going to choose. There is something called adaptive choice based conjoint, right? Based on your choice, the next answers, next questions will be different. Here it is static. I show you set of choices, set of product concept, and you are going to choose one. Not appropriate for complex product services with many attributes option, because like I said, once your attributes increases, right, and number of labels increases, number of product options will increase. If I ask a customer to go through 32 product, 56 product and choose one of them, there nobody is going to do that task, right? So these, ideally that limitations is less than 5 attributes. If it is there, try to use it. Choose one approach. Which of the two computers would you buy? So this is the standard question. In the next 10 purchases, how many of each product would you buy? So this additional one question you can ask, right? If it is for a regular daily items, right? In the next 1 year, how many times you're going to buy that product? So that will give you an idea about the market share, right? Which we did not do in this last class exercise, right? Then there is something called adaptive conjoint analysis. So this is where I'm asking the customer to first rank your attribute, right? So let's say a price, packaging, fat content, brand. Those are the 4 attributes which I showed you in that Excel file. First, I'm asking them to rank those attributes. Which attribute is most important to you, right? Then assign importance to attributes. From their side, I'm asking them to assign attributes. Finally, assess trade-off situations by evaluating which of the two presented option is much more preferred. Then only I'm going to show them the choices. Now what happens? I am taking care of them what they initially told. Let's say somebody says that price is much more important to them. But when I'm showing them the choices, they are choosing some product. They're not actually doing that assessment of the what is the weightage of those attributes. Now you can compare that to, or jointly consider that, right? Modeling high involvement purchases, new product development, right? Whenever I'm going to so let's say you are, whenever you are purchasing a car or purchasing a home, right? Because which is most important to you, that first comes into your mind, right? Okay, I have a budget limit of buying a car. I have a budget limit of, let's say, 5 lakhs rupees. So other cars which is beyond that will never come to my choice set, right? Because I have a range that my price is the most important attribute and these are the highest weightage, and I have a range for it. Similarly, let's say the color. I'll choose only these 3 colors. I cannot consider other colors, right? Accordingly, the kind of answers of the customers will vary, right? And this is more realistic for the where you there is a lot of involvement, lot of kind of sorry, lot of involvement from the customer side happens in purchasing those items. It might not happen for a regular day-to-day purchases, right? minimizes information overload, because in the beginning itself I'm asking which is the attributes are important and what are the like range of these labels, right? Some, let's say that shoe example, some customer will say I'll not spend more than $50 in a shoe or $40 in a shoe. So those choice options are unnecessary for that customer because he has put a range. More than $40 he is not going to choose. I have three options of prices: 30, 60, 90. So 60 and 90 anyhow he is not going to never choose, right? So take that out. Don't show that to that customer. Can include up to 30 attributes. In the previous case, we had only up to 5 attributes. Here we can have much more attributes. Tailored questionnaire using AI, because it will be very difficult if I ask you then accordingly quickly I'll create the choice sets. You need that algorithm or software to create the choices for you. Realistic trade-offs must be administered on the computer because it adapts to respondents' answers, not ideal for price sensitivity studies, right? Because this is where I say that high purchase involvement, where the customer is going to pay money and compare product, right? And that will be a very long-term investment, right? This is where adaptive conjoint analysis can be used. Then adaptive choice-based conjoint, it is a mix of adaptive conjoint and choice-based conjoint. Here I'm asking the customer to build their ideal product. So these are the ingredients. These are the like Dell does, right? Dell, what they say, okay, these are the RAM options, these are the processor options, these are the screen options. You build your ideal product, right? Think about any like kind of electric vehicle or any kind of product you are going to launch. Now what will say, rather than doing a conjoint, like a choice-based conjoint where I am creating product and asking customer to choose, right? Now I'll ask customer to create their ideal product, right? Create a product with all your preferred attributes, create a consideration set and establish rules, right? Then out of those different product, say that which you will be considering for your purchase, then choose best options from the consideration set. So the same step what your software was doing, you are asking the customer to do the same thing. You are asking them to first create your much more preferred attributes. For an electric vehicle, these are the attributes should be there. Then what will be your combination of attributes, what are your considerations? So they'll say that okay, these are the combination of attributes and these are the 5 or 10 products which I can look into. Out of this 5 or 10 product, which is your much more preferred product, right? So the problem is here, if you keep the price and customer select price as attribute, they will always go for the lowest option in the price, right? And that becomes tricky because that is not in your control, right? Every customer they'll choose the create a lower price, right? Which is not realistic. Studies with 5 more attributes, when you have a very large or very small sample size, only thing you have to remain, obviously it is more realistic. You are asking the customer, so I know that I'll not go beyond 5 lakh range for a car, or I'll not go beyond these three colors. I'm creating my choice or consideration set on my own, right? But only problem is that price, whenever price comes into picture, the attribute, customer might just put the lowest price, captures more information at the individual level, so it is more accurate than using conjoint based longer than CBC surveys. CBC, I'm creating choices. Now, customer is doing everything. Customer is creating attributes or finding out attributes, creating a consideration set. Out of that, creating his choice out of those 10 or 5 considerations. Right? Customer might not spend that much time with you, right? Filling it is survey is a most tiring task, right? Very few customers will spend that much time with you. Not ideal for smaller, simpler studies with less attributes. Obviously, if it is less attributes, we can just go for choice-based conjoint, right? Must be administered on the computer. Again, it needs certain technology, right? Because I cannot just keep pen and paper and like customers will draw something, right? I have to give them options so that drag and drop and they can create different product profiles, right? Then there is a hybrid conjoint analysis. Right now, it is much more preferred, right? Because data collection is again very tiring task, very problematic task. So what they do, so based on your different kind of, rather than showing all the product concept to all the customers, let's say I have 100 participants and I have 10 product choices or 100, sorry, 20 product choices. So what happens in a normal conjoint? For each of those 100 participants, I'll show them those 20 choices. So each of them have to go through those 20 product options, choose the best product out of that. Rather than doing that, So I'll create different subsample of those product choices, and I'll create different subsample of those 100 participants. So for 10 participants, I'll show only these 5 product choices. For another 10, I'll show another 5 product choices. Right. So what happens now that task becomes little easy. Rather than those customers choosing out of 20 product choices, now they're just going through 5 product choices and choosing the best option. And that is where manually it cannot be done. I'm asking to carry out this randomization by the software so that it will create 5 product out of those 20 product choices and show to randomly to 10 customers. Right. So respondents evaluate a limited number, generally no more than 9, right? 9, basically 9 to 10 conjoint stimuli such as full profiles. These profiles are drawn from the large master design. If let's say I have 20 choices, out of 20 I'm selecting 5. The software is selecting 5 and showing that to those customers, right? Respondent. Then in addition, respondent directly evaluate the relative importance of each attribute and desirability of labels of each attribute. Additionally, what I'm asking after my conjoint gets over, what is the importance of price to them? What is the importance of, like we did in that adaptive conjoint, right? What is the importance of packaging to them? What is the importance of fat content in the milk to them, right? By combining the direct evaluations with those derived from the evaluation of the conjoint stimuli, right? So direct evaluation is kind of when I'm asking the customer that how do you rate price in comparison to packaging, let's say fat content and bottle, like other things, right? So that is a direct answer what I'm getting. Then whatever I've received from the conjoint stimuli, I take a combination of them, aggregate them, and get a final answer. So it is less tiring for a customer because they are not making choices out of 20 or 50 or 100 product choices. They are making limited, which is less than 9, right? So use cases. So this was an interesting study price. This Sawtooth software is a big company who kind of a lot of they help lot of companies carrying out conjoint analysis. So Apple actually like kind of put a lawsuit on, I think, on Samsung. So what they did, Samsung has certain patent infringement. What was that patent? So I think here it is not mentioned what was that actual patent, but something which was from like kind of Apple, some typical technology Samsung was using, right? Now, when you go to the court and say that, okay, this much cost has happened to me, how will you prove that, right? So what they did, so they created different Samsung product, right? Profiles of different Samsung product. Some product has this kind of inbuilt patent which Samsung is using, which is being stolen or accused by the customer, accused by Apple that Samsung has stolen. So some product has that kind of patented technology, some product do not have that patented technology. Now customers were shown to choose between those Samsung products. So now when they saw that, okay, those customers and randomly chosen customers of Samsung, they are selecting the Samsung product, same Samsung product, other attributes remain same with this patented technology, right? Much more than the Samsung product without the patented technology, right? So there they are able to find the difference, and that's why they put, though they did not award it 1 billion, so they showed 2.5 billion. So they showed that the loss due to this patent infringement because Samsung has stolen this patent and using that. And if they using, customers are buying their product for that, right? And through conjoint analysis, they are able to show that that loss was around 2.5 billion dollars. Though the jury did not give them 2.5 billion dollars, they gave this around 1 billion dollars, around 7,000 or 7,500 crores Samsung has to pay to Apple for this patent infringement, right? And this Sawtooth software, which was the company, yeah, Sawtooth software helped them to build that conjoint analysis. MIT Sloan to design the courses, which are the courses, what should be the offerings, how many hours. They also using this conjoint analysis for that. So there are a lot of, if you search on Google, lot of companies, FMCG companies, banking, insurance companies. So for any kind of product development, conjoint analysis is a preferable method, right? Apart from your market testing and others. Any questions, any doubt on this? So I think that was your last slide. That completes your discussion on conjoint analysis. Next class onwards, we'll try to go through factor cluster analysis and market estimation. Then any last questions before we close?
I got late, sir.
Roll number 60.
20260, sir.
Okay. Anyone else? Okay, chalo, take care.